Okay, so we're going to look at starting off problem number 3. We have sulfur difluoride SF2. And our job is to draw the Lewis structure for this. So if we break down SF2, we have S and we have 2 Fs. So then we look up our valence electrons. So just as a reminder, from yesterday, we had our valence electrons listed here. So for sulfur, we have 6, and fluorine, we have 7. So sulfur, we have 6, fluorine, we have 7. So we have 6, 7, and 7. So that's where we're getting these numbers from. So when I say valence electrons, I'm not going to switch back and forth. I'm going to assume that you guys are looking at your periodic table and you know which row is which. All right, so let's look at our so we have SF2. So when we add these together, we have 14 plus 6, we should have 20. So when we draw this out, we'll put sulfur in the center and we'll put fluorine on both sides. And we want to connect this with at least one bond each. So we want to link these because remember, molecules are groups of atoms that are combined using. So each of these lines represents electrons being shared. So we have to at least connect the sulfur to both of the fluorines. We want to make it symmetrical so that both sides are the same. And then we go through and we check off our two pieces. We want to use all of these 20 electrons, and we want to make sure that we have our octet. So remember, octet is the rule of 8. So let's go around. Fluorine, we have 2 in the bond, 4, 6, 8, so that works. On the other side, we have 2 in the bond, 4, 6, 8, so that works. And then our center, we have 2, 4, 5, 6, 7, 8. So everyone has 8, so that works. 20 electrons, we have to use up 20 electrons. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that works as well. So this would be our correct structure for SF2. So I saw a lot of you guys got this correct, which was great. Those of you that did it. For chloroform, our next one, CHCl3. We want to check that one over because there were some issues with figuring out how to split this up. Okay, so let's look at the problem number 4 from yesterday. So this is number 3. So here we have, if we look at the elements here, we have C, H, and Cl. So we have C, H, and Cl for these. So these are all our pieces that we have to work with. Carbon, there's going to be 4 for carbon. Hydrogen is going to have 1 valence electron. And each chlorine is going to have 7. So we'll add all these together. We have 7 times 3 is 21, plus 1 is 22, 22 plus 4 is 26. So we have 26 valence electrons for this. Cool. So when we go through to draw this out, we're going to start with carbon in the center. So we're going to see this a lot. Carbon likes to be in the center. It likes to make 4 bonds. So we're going to put carbon in the center and we're going to surround it with the other elements. So it doesn't matter on which side you put this. So we can put the hydrogen on top, bottom, left, right, doesn't matter. But we're going to just kind of connect this with our bonds like we did before. So we have 4 bonds around this. So if we remember, hydrogen is the exception. It only needs 2 electrons. So let's take our octet and 26 electrons. So hydrogen has 2 here, and that's complete. Chlorine has 2, 4, 6, 8. Chlorine on the bottom has 2, 4, 6, 8. And then we do the same thing on this, 2, 4, 6, 8. So this would represent the molecule. We just want to double check 26 electrons. We have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So double check, make sure you guys have this for number 4. Okay, so these were the problems that we looked at yesterday. For today, we're going to do kind of the same type of thing, except we're going to come to realize that for the structures we're drawing today, we're not going to have enough electrons. So when we draw this out, we're not going to have enough electrons, so we're going to have to create multiple bonds in order for them to work. So we'll go ahead and start with an example of that, and then we'll get you guys working on those today. So let's look at our simple one here. This is going to be example number 3. So we're looking at slide number 13. We want to draw the Lewis structure. For carbon monoxide. So carbon is C, mono is 1, and oxide refers to oxygen. So we have CO. So carbon, we have 4 electrons, oxygen has 6. So we have a total of 10 valence electrons. Okay, so we're going to go through and we're going to go through kind of the same steps here. But since we're comfortable now counting the octet, what we're going to do is we're going to count the number of valence electrons first, just to make sure that we have enough. Because before we didn't have to worry about that. Now we do. So we'll make our bond here. So let's do the same process we did before, right? We want 8 for each atom. So we have 2, 4, 6, 8. And on this side, we want to add 2, 4. But before we do that, let's count the total number of electrons, right? We have 2, 4, 6, 8, 10. We already have 10 electrons. We can't add any more to this side. So there are already 10 electrons. So we can't add more. To carbon to give it an octet. So our problem is if we move electrons from this side to this side, we're still going to have the problem of now this side doesn't have enough. So one thing to note, right, if they're in the middle, they're shared between it. So these 2 electrons count for carbon and these 2 electrons count for oxygen. So what we need to do is we need to share more electrons. So what we can do is if there's not enough electrons, so if you run out of electrons, create multiple bonds. So what's going to happen is these electrons here need to be shared. So what we can do is we're going to move these electrons down here to make another bond. So what that'll look like now is we have 1 line. We're going to make 2 lines and call this a double bond. So this is a single bond with 1 line. It's a double bond with 2 lines. So these electrons at the top aren't here anymore because they are down in this bond. So if we look at this now, we have 2, 4, 6, 8 around oxygen. And around carbon now we have 2, 4, 6. So we have more electrons around carbon. We still need to get to 8. So what we'll do is we need to share some more. So we'll make another bond. So these 2 electrons will come in. And we'll have electrons on this side. And we'll have electrons on this side. And it doesn't matter if I put them on top or on the side. I just made it like this so it's symmetrical. It's the same on both sides. So if we look, we have 2, 4, 6, 8. So that's okay for oxygen. Here we have 2, 4, 6, 8. And that's okay for carbon. So that would be our correct structure for this. So really for making multiple bonds, if you run out of electrons, like something like this, you're going to have to move them from one atom to make more bonds. Because the idea is these are going to share electrons. So we want to make sure that everyone has 8. So the way we do that is by sharing more if we need to. Cool. So what we'll have you guys do is we're going to have you try out problem number 5 with oxygen. because this one's kind of a simple intro into doing more than one bond. So I'm going to go ahead and move this over. Let me try to get all this in frame. Cool. So we'll give you guys a few minutes to try out Auction. All right, so let's go ahead and take a look. We have oxygen, which is O2. We have 2 oxygen atoms. Each of these has 6 valence electrons. So if we add them up, we have a total of 12 valence electrons. So we're going to draw this out with a single bond here, and we're going to use up these electrons here. So we have 2, 4, 6, 8. Now this is full. 10, 12, and then we stop because this has 12 electrons around it. 2, 4, 6, 8, 10, 12. But we need 2 more here. So what we're going to have to do is we can't move these 2 electrons onto this side because now this is missing. So the idea is we can take the 2 here and share them between the 2. And that's what bonds do. They share electrons. So we just need to share more. So we're going to move those electrons to make another bond. And so then now we can check. We want to make sure that we have 12 electrons. And so we have 2, 4, 6, 8. So that works. 2, 4, 6, 8. So that works. And then the total 12, 2, 4, 6, 8, 10, 12. So that's how we would go about these problems. So for the rest of the problems today, you're going to see double bonds in them. So just be aware and keep count of how many electrons you have to deal with, because we can't just surround everything with electrons and call it good. We need to make sure that we're not using too many. So for this period, what we'll do is we're going to try to work through as many as we can in class. So we'll take 5 minutes to work on a problem, then we'll go over it, and then we'll take 5 minutes to work on a problem, then go over it. And then whatever problems you have left today, you guys will finish up tonight. Tomorrow we'll do more practice with this, and then on Friday we'll do kind of a review with a Kahoot. Okay, so for problem number 6, we want carbon disulfide, CS2. So this would be 1 carbon and 2 sulfur. So we know off the valence electrons, carbon is in group 4, so it has 4 valence electrons. And sulfur is in group 6, so it has 6 valence electrons. So we add these two together, so we get 6 plus 6, we get 12. 12 plus 4 would give us 16. So let's draw this out. We want to make it symmetrical so that both sides are the same. So we start with carbon in the center and we have a sulfur on both ends. We're going to connect them with one bond each. So let's start filling in electrons. We want 16 total. So we're going to do the octet as we fill. So we have 2 here, 4, 6, 8. And now I stop because this is full. So I have 8 total. So we have 2, 4, 6, 8. We have 10 here. 11, 12. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, 12. This is 14. So 2, 4, 6, 8, 10, 12, 14 with all of these. And 2 more here would be 16. So we ran out of electrons. So what we need to do for this is we need to create more than one bond for this. So we have 2, 4, 6, 8, 10, 12, 14, 16. So we're going to have to move 2 electrons here. So we're not finished yet because this has 2, 4, 6, 8. The center one has 2, 4, 6, 8 as well. And this here has 2, 4, 6. So we can move these electrons here to make another bond. So we could have S with 2 electrons here, C, and we could have our electrons that look like this. So this is one way to create our bond here. So this is one possible way. We could have done this a different way. So say we started filling in the electrons here. We had 2, 4, 6, 8, 10, 2, 4, 6, 10, 12, 14, 16. So say we filled in these outside ones first and left this carbon in the center. We'd have the same problem. 2, 4, 6, 8, 10, 12, 14, 16 electrons. So we'd have to share electrons. So we'd move electrons in here. So now we made a double bond here because those electrons have moved down. We can do the same thing for the other side. We'll move the electrons here. So those come down. And we make a double bond as well. So either of these are fine because both of them, they fill the requirement of 16 electrons in an octet. So we have 2, 4, 6, 8, 10, 12, 14, 16. 2, 4, 6, 8, 10, 12, 14, 16. And each element has 8 electrons around it. Here we have 2, 4, 6, 8. Carbon, each bond counts as 2. 2, 4, 6, 8. And sulfur, 2, 4, 6, 8. Same thing works here. 2, 4, 6, 8. This sulfur is the same on that side. And we got 4 bonds, which are 8 electrons. So 16 electrons in octet. So we have 2 different ways to write this. So both of these I would accept. This is symmetrical. So that we can say that this is the better model. So if it's symmetrical, if you have 2 different ones and you're trying to figure out which one's the better one, it would be the one that's symmetrical, typically. It gets more complicated than that. There is a way that we can check to make sure one of these is a little bit better than the other, but that's kind of beyond the scope of what we're doing. Both of these do exist in nature. It's just, well, this one is more preferred, and we can say it's due to it being symmetrical, because we want to think that these sulfur want to have kind of the same configuration. So we're going to look at hydrogen cyanide, HCN. So if we break HCN down into its parts, we have hydrogen, we have chlorine, and we have nitrogen. So we have one valence electron in hydrogen, 4 for carbon, and 5 for nitrogen. So when we add these up, we should get a total of 10 valence electrons. So let's go and draw this out. We can't put hydrogen in the center because hydrogen only likes to make 1 bond. So if we're looking at this, hydrogen's already full because it has 1 bond here. So far we have 2, 4 electrons. We're going to do 6, 8, 10. And now we're going to stop because we used up our 10 electrons. If we count, let's look at our octet. Hydrogen has 2, and that's okay because it wants to. Hydrogen's our exception. Carbon in the center here has 2, 4, 6, 8. So this is a total of 8. And then this nitrogen here has 2, 4. So it needs to have 4 more electrons. So it's going to have to share more. So if we look at this, carbon center still has 2, 4, 6, 8, but now nitrogen has 2, 4, 6. So it's better. It still needs 2 more. So we're going to make another bond. So we should get this compound here because we check for 10 electrons. 2, 4, 6, 8, 10. That works in our octet. So hydrogen only needs 2, so that's okay. Carbon in the center has 4 bonds. Each bond's 2 electrons. So 2, 4, 6, 8. That works. And then we have 2, 4, 6, 8. So all those work, and we're good.